A ball rolls off of a table. The table has a height h, and the ball has an initial velocity v0. We want to know three things: how long it takes for the ball to fall, the horizontal distance from the table that the ball lands, and the final velocity of the ball right before it hits the ground. First, we must recognize that there are two dimensions, the x and y dimensions. The only acceleration acting on the ball is gravity, so this is an example of projectile motion. The fundamental principle of projectile motion is that we can treat each dimension separately. This means that we can have separate equations for the x and y dimensions. Given that, how do we choose what equations to use? We start by listing out our known and unknown values for the x and y dimensions. First, we have the acceleration. The y acceleration is downward at a rate of g, 9.81 meters per second squared. Because it's downward, we treat it as negative. There is no horizontal acceleration, so a sub x is 0. Now we have the initial velocity. The ball is moving horizontally, so this speed, v0, is the initial velocity in the x direction. Right as it starts to fall, the ball hasn't had time to move down yet, so its initial y velocity is 0. We're given the height of the table h, which is also the distance that the ball falls. So, delta y equals minus h. Why is it negative? Well, if delta y was positive, that would mean that the ball went up. Since it falls down, it must be negative. The unknowns of the system are the fall time t, the horizontal distance delta x, and the final velocity. These are the values we want to solve for. Let's look at the kinematic equations and pick one that'll let us solve for these unknowns in terms of the known values. One way to pick an equation is to cross out the ones with values we don't have and don't want yet. We don't have and don't want final velocity yet, so we'll cross these out. So, we choose the delta y equation because it only has one value we don't know, time. This means that we can use it to solve for time. Let's put what we know into this equation. Delta y is minus h. The acceleration is minus g. The initial y velocity is 0. We can cancel out the negatives on both sides. Multiply both sides by 2 and divide by g. Then take the square root. The fall time equals the square root of 2 times h divided by g. Now we can try solving for the horizontal distance, delta x. It's important to note that since we found the time, we can count it as a known value. This lets us pick the delta x equation because we now have everything we need. The x acceleration is 0, so this term goes away. The initial x velocity is v0, and time is the quantity we found in the last equation. If you calculated a numerical value for t, you can use that here instead. So, delta x equals v0 times the square root of 2 times h divided by g. Now we want to know the final velocity. The final velocity will be the vector sum of the x and y final velocities. The reason why will be covered in a future video on vector addition. So, we will use the Pythagorean theorem to get that the final velocity is equal to the square root of the final x velocity squared plus the final y velocity squared. Because there's no acceleration in the x direction, the x velocity should be constant. So the final x velocity will just still equal v0. We can use the kinematic equation for final y velocity. The initial y velocity is 0, and the y acceleration is minus g. We could plug in the expression for t that we found earlier, but it will be simpler to just calculate that number first by plugging in values and then putting it in here. Once you calculate the final y velocity, you can put it into the equation for the final total velocity. If you'd like to test your algebra skills, you can try plugging in the expressions and arriving at this final equation. For the direction of the final velocity, we will take the inverse tangent, or arctangent, of the y velocity divided by the x velocity. The reason why will also be covered in our vector addition video. We now have the final expressions in terms of the known values, so we're done. We can plug in a couple of example values to test it out. The table has a height of 1 meter, and the ball is initially moving at a speed of 0.6 meters per second. The acceleration due to gravity, g, is 9.81 meters per second squared. This gives us a fall time of about 0.452 seconds and a horizontal distance of about 0.271 meters. We can calculate the final y velocity to be negative 4.43 meters per second and the final total velocity to be 4.47 meters per second at 82.3 degrees below the horizontal. It's always helpful to check if your answer is a reasonable value, and these seem good.